Okay, I'm going to try something a little bit different this time. I don't know if it's going to work. I hope so. So, frequency tables are what we're going with today. So, a frequency table is just like the dot plots we talked about Friday. Do y'all remember what it means if I say frequently, like how frequently something happens? Frequently is asking how often. If I ask how frequently do you ask to go to the nurse, I'm asking how often are you up out of your seat asking me for that. And frequency tables are going to show frequencies, so they're going to show us how often, but these are going to go into a table. Table is a capital T for T-charts. So if you don't remember, the dot plots went on the number line. Frequency tables are going on a table. So use the data and the distance biked in kilometers to create a frequency table. What letter does table start with? T. Right, so if y'all look right here, a table is just one big T-chart. And remember, when they give you data or a graph, you need to look at it. You need to study and analyze it. These digits are the distances biked in kilometers, kilometer, tomato, whatever. These are like miles. So on a bike, there's a distance of 1 kilometer, a 9 kilometer bike, a 6 kilometer bike ride, an 8 kilometer bike ride. So we're going to create a 2-column table, 1, 2. One side will represent the distance. The other side's going to represent the frequency. So over here, I might just write km. What do y'all think that means? Kilometers. Okay, and over here, we have to write the word frequency. And I'm going to capitalize it because these are titles. They're subtitles. The big title I'm going to put is distance biked, because if they use a short title, I'm all about copying it. Distance capitalized, bike capitalized. At this point, I'd probably get up just to make sure that they capitalized, spelled frequency right, put the period, all that stuff. All right, so this is a table, and we're going to put our data on this table, and the numbers represent kilometers that someone biked. What order do you think we should put the numbers in, y'all? And then I'd go sit back down. Least to greatest. Very good. Just like dot plots. This is very important. Least to greatest. And remember, we're only going to write each one time. So I'm going to come over here and study. I've got 1s, 2s. What else? 3s. Do we have 4s? Yep. 5. Yep. 6. Yes. 7s. No. 8, 9, 10, 11. So we're going to write everything but a 7. So I'm going to have to be real careful here. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's hard videoing, but, oh, and there's a 12. So y'all are going to have to write smaller than that, but you get what I mean. All right, and what I like to do then is just kind of do a little small line. And we're going to do these 2 different ways. So, because frequency chart tables, they can go in different ways. So, let's go mark out every time we see a 1. 1, 2. We're going to use tally marks. So, we're going to go 1, 2. How many times do you see 2 kilometers? 1, 2, 3. Y'all should be marking these as y'all see them. Now remember, just like the dot plots, you want to be accurate. You want to be correct. So if that's 2, then this is 2. You add 1 more to make 3, because 3 should be bigger than 2. All right, let's go count our 3s. Mark them out as we count. I see 1, 2, 3. 3 should equal 3. Let's go find our 4s. 1. 5s. 1, 2, 3. 3 of them. 1, 2, 3. 6 kilometers. 1, 2, 3, 4 of them. 3 should equal 3 with a 4. 8 kilometers. 1, 2, 3. 1, 2, 3. 9. 1, 10, 1, 2, 11 is 1. I think I missed a 6. Oop, gonna make 5 because there were 5 6s, and then 112. All right, and there's your frequency. And then number 3 says, write a number that represents how often, could be tally marks, title. We've already done all that. All right, so remember, y'all, digits, your numbers need to be least to greatest all the time on a chart, on these data charts. All right, so I'm going to see if I can trick you up. I'm going to just ask you a couple of questions. Which distance was biked most frequently? 6 kilometers, very good. It has the most marks. Which bike distance was, which distance was biked least frequently? Yep, 4 kilometers, 9 kilometers, 11 kilometers. Okay, now I'm really going to try and trick y'all. How many bike rides were taken in all? And I don't want you to answer out loud. I want you to think and raise your hand when you think you know. How many bike rides were taken in all? Give them a few minutes and then ask them what they think. 2, 4, 5. It should be 25. All right, and so what do y'all think? I want y'all to say it at the same time. Ready, set, go. 25. How did you get that, so-and-so? Oh, you added all the tally marks. That's good. Or someone might say they counted all the numbers. I agree. This is a bike ride of 5 kilometers. So that's 1 bike ride. And then another bike ride was another 5. And this bike ride was 8. And this bike ride was 12. So if you have 5 rows and each row has 5 in it, that's 5 groups of 5, which equals 25. So y'all can kind of talk about that. All right, we're going to do this again. So grades scored on tests. So when we see a 70, that's a test score. So one side of these are going to be the grades. Capitalize it because this is a subtitle. It's a smaller title. And the other side, because these are frequency tables, they're going to say frequency. And what does that mean, frequency, y'all? How often? That's right. We're going to write that off to the side. Your arm won't fall off. You'll be okay. And the big title is that these grades are grades on tests. So I'm going to just write test scores. So this is my big title, test scores. And these smaller ones would be the subtitles. And I'd get up and go walk around. Make sure that they wrote the titles, that they wrote how often, it's capitalized, because if you're not getting up, making sure they're doing quality work in what you're asking, it's kind of pointless. All right, and then I'd go back and ask, okay, John, what do you think, which test score should we write first? 75? I don't agree. Anyone else? 70, why 70? Right, because it's less. Okay, so remember when we do these numbers, when we list all these numerals, they must be least to greatest. So we have a 70. I see 75. I see 80. 85. 90. A 95 and a 100. All right, we're going to kind of separate each one of these. And of course, mine would look much better if I weren't recording with one hand. Instead of tally marks, which we did up there, this time I'm going to just use digits. So how frequently, y'all, do you see a score of 70? 1 time. So we're going to write the digit 1. And we see 75 twice. And 80 is 1. 85. 1, 2, 3. 90 is 1, 2, 3. 95 is 1, 2, 3, 4. 100, 1, 2, 3, 4, 5, 6. So a frequency chart can use tally marks or just digits. What is that line for? That's Oh, because I should have read directions. And we're going to create a frequency table and a dot plot. All right, well, a dot plot's on a number line. What order do the digits have to be? That's right, same order. So we're going to have a 70, just a second, Owen, 70, 75, 85, 90, 95, 100. And we need a little hash mark above each digit. And we need, on a dot plot, they use dots. 70 was seen once. 75 was seen twice. Should be equal, remember? And then once. Owen, go take it to Daddy to open, please, baby. 3 times. 3. 3 equals 3. 4. So the 3 should be same size. 4 should be a little more. And then 6. And dot plot should have titles also. So I'm going to put, these are test scores. And the numbers along the bottom were the grades. And we don't have to write the word frequency because the dots are frequency. Now, I did that fast. I would do it much slower and, neater. But we just made a frequency table, a T-chart, and a dot plot for this data. Which score was made most frequently? A 100. Yeah. Which score was seen the same amount of times? 85, 90, or 70, 80? How many people took this test? How many people took the test? And again, every digit in here is a time someone took a test. So these aren't only test scores, but they're kids, because somebody had to make an 85, and somebody had to make 100, and somebody had to make a 70. So you could count each one of these dots, or you can count each box, but talk about that. And then on the back, we're going to answer questions. So I would say, all right, whole class, I want everyone to read us about Mr. Dominguez. He collects height of data. He represents in a dot plot. All right, boys, read us. Well, before we read the question, let's look over here. What are these digits along the bottom representing? Yes, they're mixed numbers or some are whole, but what is 53 and 5/10? What's 55? Their height, that's right. So all of these are heights in inches. What are the dots? What do they represent? How frequently? Good, they are how frequently. What else are they, though? It says he collected data on the heights of his students. So these are the, okay. So this is what I'd love to see, guys. I'd love y'all to tell me with just a little quick little drawing or something that, yeah, these are frequencies. Like I can see right here that 55 inches is the most frequent height in his class, but each dot is a kid, too, that was measured. One kid was 53 and 5/10, and another kid. All right, so now that we know that, girls, read us question 1. All right, what are we looking for, class? Students. Which students? 54 and 5/10 inches tall. All right, so how many students were 54 and 5/10 tall? 4, that's right, y'all. 4. Good. Boys, read us the next one. How many students did Mr. D collect data about? So we're wanting the students Mr. D collected data about. How many kids did he collect data about? How are we going to find that answer? Count the dots is right. Very good. Let's count. Let's just watch my paper and let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. There were 22 dots, which we said were kids. He had 22 students in his class. All right, I'm going to read the next one. How many students are more than 55 inches tall? Who are we looking for? Students. Which ones? More than what? 55 inches tall. Did it say that it wanted kids that are equal to 55 or just more? Just more. Okay. So here's 55. We don't want the ones equal to 55. We want all the students more than 55. So that's 3, 4, 5, 6, 7. And then get someone else to read this. And we want to know students that are more than 56 inches tall or less than 54. So we want to know how many kids are more than this or less. When you have a choice, you get to add both sides. It's like cookies. You how many peanut butter and how many chocolate chip? Well, all together we have this many. So how many students are more than 56 inches tall? So here's 56, y'all. It did not say 56 or more. It just wants more than 56. 2 kids. So over here, I'm going to write that there were 2 kids. Less than 54. Again, they didn't say equal to 54. They said less. This is the only number less, which has 3. So how many students are this or that? Well, together, 5. We want the height of most students. Most kids are what height? 55 inches. How do y'all know that? Yeah, because it has the most dots. This is the most frequent height. Okay, you could call on that kid not listening or the one you see miss it a lot. What does it mean, difference? What's a difference? Oh, it's the answer to subtraction, so I know I'm subtracting. I want the difference between students who are 55 inches or less. So 55 inches or less, and students who are more than 55. So we want a difference between the students who are this and students who are more than that. 55 or less. Now this one's tricky because this one says 55 or less. So in this case, we get to grab 55 and anything less. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 students are 55 inches or less tall versus students who are more than 55. Well, not 55 or more. More. 3, 4, 5, 6, 7. And the difference between these digits is 8. All right, now we're going to use this frequency table. Before we read it, let's read the problem about it. Whole class, I want y'all all to read. Stay together. Adam asked several people how many hours they sleep. He represents it in a dot. Okay, so look over here, y'all. When you read 6 hours, this is 6 hours of what? Sleep. Very good. I'm going to add that. That'll help me understand. So the question, girls, read us the question. All right, what are we looking for, everyone? Hours slept most people. All right, well, which time do we see most frequently slept? 8 hours, that's right. That has the highest frequency. That means most people sleep 8 hours. Girls, read us the next one. Boys, summarize. What are we looking for? We're looking for people sleeping less 7.5 hours. Did it say they wanted the people who slept 7.5 hours or just less? Yeah, just less. What's less than 7.5? 7, 6.5. Okay, so we want the people that slept less than 7.5. Now my question to you is, where are the people? Because these are sleeping hours. Oh, the frequency, you're right. Because one person slept 6 hours. 2 people slept 6.5. All right, so how many people slept less than 7.5? 6, because 1 plus 2 is 3 plus 3. All right. How many more people slept? Blah, blah, blah. All right, so how many more than? How many more are here than here? We want to know what is different, and the answer to subtraction is a difference. So in front of than, we want people with 8 or more hours. 8 or more. How many people get 8 or more? 7. Good. Versus people who sleep, look at this trick, 7 or less. So you can grab 7 or less than 7. That's that 6, because 1 plus 2 is 3 plus 3. So how many more? What's the difference between 7 and 6? 1. That's right.